All right, I got a lot to get through, and at times it may sound like I'm an auctioneer up here because I really want to get through a lot of material. And you can always go grab the slides at the URL that you see at the bottom here. You got a GitHub repo called Talks, and there's a folder in there called Swift, and you'll find a PDF of all of these slides there. One thing that's misleading here, you see this logo up here, KCBC 2022. I just used the theme from my slides from last year's KCBC conference, and I really want to present this at the conference this year, but I haven't been accepted just yet. We'll see how that goes. A few other things I wanted to mention. Warp Terminal is something I've been getting really excited about lately. It's a Mac-only thing, but if you're looking for a nice terminal application, one of my blog pages goes into a lot of detail about Warp Terminal. I really like it. So here's the URL for my blog. You'll find Warp Terminal there. And also, my first iOS app is out in the App Store now. It's called Feather Weather Forecasts. A lot of work into this. I think it's really cool. So if you've got an iPhone, check it out. You know all about me already. This is more for a conference talk. So what is SwiftUI? Well, it's a framework that you can use from Apple for building all kinds of applications for their platforms, like iPhone, iPad, for Mac, even for tvOS. Some of the features in SwiftUI are specific to a certain platform, so a lot of your code will work across all of them, but not all of it. It is an alternative to the framework that came before this. It's called UIKit, and many of the SwiftUI views, and we'll be talking about what views are in a bit, a lot of them are UIKit components. So comparing SwiftUI to UIKit, well, the big thing is that SwiftUI is declarative and UIKit is more of an imperative framework. It's just a different style of writing your code. It emphasizes using structs over using classes. We're going to be talking about the differences between structs and classes later. You write a lot less code to do the same things, and that's really the big draw for a lot of people, is that they're just more productive working in SwiftUI than they are in UIKit. Performance is a bit better. There's more strict requirements on the iOS operating system. You have to have at least iOS 13, but that's pretty old now, so most people have a phone that's on a newer version than that. There are some features in UIKit, things that you can do that you just can't do in SwiftUI. And so in some cases, you have to bridge across to make use of parts of UIKit in a SwiftUI app. And UIKit often used a thing called storyboard, where you drag and drop components around. And you can do a little bit of that in SwiftUI, but it's not really tailored toward that. It's more tailored toward writing code. When you're doing this kind of development, you're going to be using Xcode as your IDE. So this is a free IDE from Apple, and you probably have heard many people complain about it. But in my experience, once you use it for a while, it turns out it's actually a nice IDE. Probably the biggest rub against it is that it's massive. And so they tried to make it less massive by not including the SDK for every platform. And so by default, you're just going to get what you need for iOS and Mac apps. But if you want to develop for other platforms, like say watchOS for Apple Watches, you have to ask it to install that. And I did some watchOS development. And so after I added that, I had 23 gig just for this IDE. That is insane. So if you could look past that, you've got plenty of space. It actually is a nice IDE. It has really good support for Git. Makes it really easy to do things like create a remote Git repository straight from your IDE and then push changes out to it. I've got a lot of detail in my blog about Xcode if you want to dig into it further. So again, there's the URL. Go to the Swift category and look for Xcode. So if you want to create a brand new project, it's really easy to get started. You just fire up Xcode, select File, File menu, New, Project, and then that'll present you with a dialog where there's a bunch of templates for kinds of things you can create. And so you want the app template, and then you enter in a name for your application. You want the interface type to be SwiftUI and the language to be Swift. You tell it where to store this thing. If you want, you can turn on support for Vim mode in your editor if you like that sort of thing. And you also can configure a tool called Swift Format so that it will automatically format your code when you save changes, which is a feature that I really like. And so here's what Xcode looks like. There's a lot of pieces to the IDE. On the left, we've got the project navigator. And up at the top, you see a bunch of little buttons. Well, those are different kinds of navigators that you can go to. For example, one of them the one with the kind of diamond with a check mark in it. So that's where you go to run your test. But most of the time, they'll be in the very first one, which is the project navigator, where you can see all the files that are inside your project. And you've got, of course, the editor area where you're going to write your code. And then this piece is called the canvas. And what goes inside there is a preview. So if you're working on one of your SwiftUI views and you want to play around with it, see how it looks, maybe make changes in your code, the nice thing about a preview is that it automatically updates as you're making changes in your code. It's much faster than asking Xcode, will you please rebuild my whole app and run it in a simulator, which is another common thing people do. It's for quick looking at changes in your code. There's an inspector on the right. So if I select something in my code over here, I can see some details about the thing that I selected. There's a debug area, which you can't see, and there's many ways to get to it. But one way is you just grab this bottom line and drag it up, and then that debug area appears. So the previews that I mentioned are really great for testing out a single view that you're working on. So I might have a large application with lots of views, and I could focus, say, on one screen at a time or one view within that screen. Again, it automatically updates when you make changes to your code, and the reason you want to use this is it speeds up development. But a big downside is that there are certain things you could be doing in your code that just don't work when they're running in a preview. And so then you'll have to run it in a simulator instead. There's some really important keyboard shortcuts to know about. You're often wanting to hide that preview area for a while and then bring it back later. The Command-Option-Return toggles the display of it. And then sometimes the preview stops running. Like if you got certain syntax errors in your code, the preview is like, I don't know what's going on, and it stops. And then you fix the error, and it doesn't automatically start again. And so you have to press Command-Option-P to tell it, can you start running again? So when you're running a preview, there are some buttons down here that are important. These two toggle between whether it's running live, where it's responding to you interacting with things in your view, or do you want it in this select mode where if I click on a component here, it highlights the corresponding code on this side. So you can switch between those two modes. Then you can show variants. So right here, we're looking at just one version of this view that I'm working on. But if I say that I want to see variants, it can show me side by side, what does it look like in light mode? What does it look like in dark mode? Or what does it look like in different orientations? Landscape, portrait, upside down landscape, all these different orientations. And then last, dynamic type. So the user on their iPhone can go into their settings and have a preference for how big they want their fonts to be. And you might want to see how this looks in 6 different font sizes to make sure it looks good in all of them. So that's all really handy for looking at different ways of displaying your view. Then when you're ready to run your code outside of the preview, you can either run it in a simulator or on a real device. And so going back to here, you see up at the top where it says Marks 14 Pro. Well, that's a drop down. And if I click that, I'll get a list of a bunch of simulators or as many devices as I have plugged in right now. And so that's where you select which simulator you want or which real device you want. And then after that, you just need to click on the triangle at the top or press Command-R. So the triangle that I'm referring to is right there. It's like the run button. And so that will then run your app in the selected simulator or in a real device if you've selected one. When you get started in a SwiftUI app, this is the code it's going to give you as a starting point. And I'll be going through a more detailed example later. Let's just talk through what you have as a starting point. So this little annotation is saying this is the beginning of my application. And typically, you don't have to change anything in this file. All this is saying is that I'm creating a window, and what I want to display in the window is this. And that's what's defined over here. So you usually don't touch this. And you come over here and start writing some code. And so view is a protocol. And protocols are like an interface in another language. And so because content view is a kind of a view, it means I have to do certain things. Really, the only thing it's requiring that I have to do is I have to have this body which is a computed property. We'll talk about computed properties more later. But this computed property is going to give me some kind of view. And then inside here, I can use some built-in views and build up what it is I want to display. So a V stack, as you might guess, is just a vertical stack of things that I want to display. And I want to display two things. There's an image, and it's just that globe icon that you might have noticed earlier, and then a bit of text. Well, a system name is referring to the name of an image that comes from a library called SF symbols, and we'll talk about those more later. And then these two lines, these are view modifiers. So image is a view, and then I can say I want to modify it in a certain way. And so most of the view modifiers, they operate on a view and then return a new view. And so here I get a new view based on that image that's a different size, and then I apply another view modifier to it to say I want it to have a certain color. This text view, I could add modifiers to it to set its color or font size, but I'm not doing that here. So I've got a vertical stack of these two things, and then I'm adding some padding around the V stack so that these things aren't right next to the edge of the screen. And there's a default amount of padding it adds if I don't tell it that. This bit down here is related to the preview. If I don't have this, I can't look at a preview inside Xcode. But if I have it, there's customizations I could do here as well. But usually you just say, hey, show me the thing in a preview. So that's what you get as a starting point, and then you start editing from there. Some slides I'm going to skip past because I know I'll run out of time. And one of those is the debug area. As you might guess, like in most IDEs, there's a way to set breakpoints and step through your code. And so this slide just summarizes how all of that works. Really, the main thing to know if you're an old school debugging person is that if you want to throw a bunch of print statements in your code and you just want to see the output and you're not actually using breakpoints, then those appear in the debug area. So print statements. All right, so let's talk about the Swift programming language itself. So this is an object-oriented and functional programming language. It is strongly typed and has a lot of support for type inference. So there are many cases where you don't actually have to specify the types, and we'll see examples of that coming up. So Apple introduced this in 2014, and a year and a half later, they made it open source. It's built on the LLVM, and so this is a little bit like, for the Java people in the crowd, like bytecode, Java bytecode. It's something that can be targeted by many programming languages, and Swift is just one of those. You can interoperate between Swift and Objective-C code, the language that was popular for Apple platforms before Swift. And you can use Swift not just for UI development, but also for server-side development. There's a framework called Vapor that is usually used for that. And so if I wanted to implement a REST API in Swift, that's probably the way I would go, is to use Vapor. And it turns out it's pretty easy to do. And my blog has a page just on Vapor. All right, so let's get through some of the basics here. There are some primitive types that are supported by Swift, all the things you might expect. Then there are some non-primitives like functions, structs, and classes. We're going to talk about the difference between those in just a bit. Enumerated types, and then protocols. As I said earlier, protocols are like an interface in other programming languages, but there's some terminology that's different between Swift and every other programming language. And if you use the wrong terminology, people will know you're not a real Swift developer. So if you said, you should implement this protocol, they'll be like, what are you talking about? You're not one of us. You have to say you want to conform to a protocol. You don't implement a protocol. Implementing is for interfaces. So just some terminology differences. There's lots of kinds of collections built in, the ones you would expect: arrays, sets. Dictionaries are like maps or hash maps in other languages. There's ranges, like ranges of characters or ranges of numbers. A tuple is not an actual type. There's not a name for it, but it's a concept that is supported in Swift, so you can have an ordered collection of things. Some basics of the syntax. You declare variables with the let and the var keywords. And this is kind of unfortunate for JavaScript developers, because here, let means it is immutable, and var means it's mutable. Makes sense that var would be mutable. It can vary. But unfortunately, in JavaScript, let is what you use for something that is mutable, and you use const for immutable. So that's a difference in keywords to get used to. You do not terminate statements with a semicolon. And in control flow statements, when you have a condition like in an if or a while loop, you don't put parentheses around the condition, but you must put curly braces around the statements. This is an interesting trade-off, and one that I really like now that I've gotten used to it. You see so many fewer parentheses in Swift code. And we'll see examples of that in the very next slide. But here I want to talk about type inference. I mentioned that most of the time, or in many cases, you don't have to specify the type of a thing. And so if I declare this variable b and I say its initial value is true, it can infer that that's a bool kind of variable. And this infers a string. It has to be surrounded by double quotes. This is an int. This is a tuple. This is an array of int values. It looks at all the values you pass and figures out that this is the type, but I also could write it like that. And then the next one, this is how you write a literal dictionary of key value pairs. And it can infer from that that all of my keys are strings and all of my values are ints. And so that's the type that it infers for me. Yeah.
Quick question. With that last example dictionary, if the values were not all the same type, what would it infer? Is there a generic object or?
No, well there is a generic thing, but I think if I, for example, made this 21.7,
yeah,
there's a super type of int and double that I think that it would pick for me.
What if you made a string?
Yeah, then it would have to be, I think that there's an any type, but I haven't seen that in code.
But it will figure out what the.
I believe so, or alternatively, it might just be a compile error. I'm not sure about that.
Thanks.
Yeah. Another interesting place where type inference comes in is working with enums. And so slipping into a bit of SwiftUI code, here I've got a text view, and I want to add a border around it, and I want to make the border red. Well, this view modifier expects me to pass it a color, and color is an enum type, and red is one of its values. And so here I could say color.red to be explicit, but I also could just say .red because it knows border wants a color. I just have to tell it which one of the cases I want to use. So that comes up a lot in SwiftUI code where you take a shortcut of just saying dot and some case of an enum because it knows what kind of enum it has to be. So here's all the control flow syntax. And the big thing that jumps out here, no parentheses around conditions, but the statements that go with the control flow must have curly braces. So I kind of like that trade-off. And in a lot of cases, if you have something like this, and there's only one statement and it's really short, you'll see the whole thing on one line, all the curly braces as well. Functions are interesting in Swift. At first glance, it seems like this is really odd and very different from other programming languages, but I've really gotten used to it now. So you declare them with the func keyword, and the confusing part is how you declare the parameters. So every parameter has a name and an optional argument label. It's like every parameter has two names. The argument label is what you use when you're calling the function, and then the parameter name is what you use inside the function. So why would you want to have two names for the same thing? Well, Apple would say it's because they want to make the calls read like English. And you'll see an example of this on the next slide. So really, there are three options for your parameters. They can be named and you don't specify an argument label, in which case it defaults to the same as the name. Or it can be named and it can have an argument label. Or it can be positional. And you indicate that by using an underscore for the argument label. Now, at first glance, you might think, well, I don't really like any of this stuff. I'm just going to make every parameter be positional because that's what I'm used to. But that's really unusual in Swift code. In fact, usually you only have a positional parameter for the first one, and only if the meaning of the first parameter is obvious from the name of the function. And we'll see an example of that on the next slide, too. Now, you might think, if I've taken the time to give a name to all of my parameters, that I can put them in any order I want because they're named. That is not the case. they must be in the order that you declared them. And again, the reason is that they're thinking that you picked the names so that the call would read like English. So let's look at some examples. Here, I'm not doing anything that's very readable. I'm just trying to show the syntax. So this first one, my argument label is an underscore, and then I have the parameter name, and then it's type. This one, I have a parameter name, but I don't have an argument label, so it's going to default to P2. And then this one, I have an argument label and a parameter name. And then I'm done with my parameters. This is how I specify the return type. And so if I want to call this, I call some name, I give it a value. That one is a positional parameter. There's no name. The second one, the name is P2 colon, and then the value. And then the third one, I must use A3. I can't use P3 because it has an argument label, so I'm supposed to use that name. Okay, this seems horrible, right? But I think it will seem a little better if I show you two more examples. So here I have a simple function that's just going to add two integers. And so I make the first one be positional, because you can tell from the name that I'm adding numbers. But you don't usually make the second one also positional. And so what's common is to use a word like to. I want to add some number to this number, returning an integer. And so inside, I have to use the parameter names. And so that's what I'm doing. And if I only have one statement, it automatically returns the value of that expression. And so here's an example of calling it add 2 to 3. So the Apple people look at this and say, that's beautiful. It kind of reads like I wouldn't want to see add 2, 3. That'd be confusing. But here's a better example of that. Here I want to get the daily percentage of some whose type is an ingredient, some kind of struct, I suppose. And then I want to know what percentage that is in some food, but I give that argument label of in, and what's coming back is some double value. And now look what happens when I call it. Get daily percent. Is that beautiful? Bad? I don't know. But that's really what Apple is going for, is for you to make a lot of your function calls look like this. That is the reason why they have these argument labels and why they require your parameters to be in the order you declared them. Because you wouldn't want to say, get daily percentage in ice cream of sugar. That wouldn't be right. Yeah, so that's what's going on with functions and stuff. Structs versus classes. So they have a lot of things in common. Both of them are defining a named group of properties and methods. Both of them can conform to any number of protocols if I want them to do that. Both can define an initializer with this name init, and that's like a constructor in other programming languages. Both of them can define properties that are either mutable or not mutable with the let and the var keywords. They can define computed properties, and we'll see an example of that coming up. They can define methods with the func keyword, and then you create an instance by calling the type as if it were a function. You don't use a new keyword. You just say, for example, car, left paren, arguments, and that creates a new instance. There's a lot of ways that they differ, and the most important one is that structs are value types and classes are reference types. And so this means that if I wanted to have a couple of objects referring to the same other object, that thing better be a class so that it's a reference type and I can refer to the same one. Structs, on the other hand, those are value types. And one of the impacts of that is that if I make a change to one property in this struct that has 10 properties, it makes a new copy of the whole thing. Because it was immutable, I have to make a new copy of it. It turns out that that is favored in SwiftUI because they want to quickly be able to create new versions of views. And so all the views end up being structs. Structs can't inherit from anything else, but classes can. And if I don't write an initializer, structs automatically are given one for initializing all of its properties, but classes don't get one for free. You have to write that if you want it. So here's a side-by-side example. I've got a struct on the left and a class on the right, and they're doing the same thing, really. They both have the properties x and y. I'm describing a point. And notice I have var on those. So that means I'm going to be able to change those values later. Then I have a method that can compute how far this point is from the origin. Just a little bit of math there. I've got a log method that prints out where the XY value is. And this is using string interpolation. Notice I've got string in double quotes, but it's this slash paren and the closing paren. That's what does the string interpolation. I can put any expression there, and it'll insert that value into my string. And here I have a function that's going to make a change to my point. And so I pass it in a delta x and a delta y value, and it modifies x and y. But because this is a struct, I'm not modifying it in place. I'm actually creating a whole new copy of the struct that has these different values. And so structs require methods like this to use the keyword mutating to make it clear that this is kind of expensive compared to other things. So here's an example of using it. I create a new point and I'm passing in the x and the y values. So notice I don't have an initializer, but I get one for free, and it just looks at all of my properties, my stored properties, and gives me that initializer for free. And here I can print out a distance from the origin. But notice that I don't have parentheses after this. That's because distance from origin is not a method, it's a computed property. So look at it here, it's got a var, there's no func keyword there, its type is double. And every time I refer to that property, it will just compute the value again. And so that's why I'm not calling a method here. I'm just getting the value of a computed property. Here I'm calling the translate method, and it is making a copy. This is kind of interesting because down here when I log it out, you might think, well, I didn't capture the copy. How is it printing out this new value? And the answer is that behind the scenes, even though it's making a copy, it's updating this variable to hold the copy. The old one went away. The class code looks very similar. Main differences are I had to write an initializer, and I didn't have to say that translate was mutating, because that's just kind of assumed for classes since they're value types. And then all this code looks pretty much the same. Yes?
For the copy, does it get rid of the initial one in terms of like memory, or is it still lingering out there?
No, it's getting rid of that for me. All right. Swift lets you make extensions to an existing type, and I'm going to get through this one pretty quickly, but this is a really interesting thing that I could say, all right, there's a date type built in, but I want to add an extension to it. And the extra things I want to be able to do that it doesn't do by default, I want to ask it, well, what day of the week is it? And I want to get back a string like Monday. Or I want to find out the date that is a certain number of days past that one. Like, tell me the date that's 3 days later. And I do that calculation. And finally, I want to do some formatting, and I want to get back the month and the day, and I want it to look like this, like 2/10 for February 10th. So I have added these things. This is a computed property. This is a method, and this is a computed property. So over here, I can create a date object, date that now for the current date, print it out, and then I can get the day of the week is Friday, days after, 3 days later, bump that up for me, and then some simple date formatting. So this is a common thing to add convenience things onto existing types. A big feature of a lot of modern programming languages is to support optional types. And so what this means is that if you don't say a thing is optional, it must always have a value. It can't be null or nil or whatever that is in the programming language you're using. In Swift, it's nil, and nothing can be set to nil unless you say its type is optional. And so to do that, we just add a question mark to the end of the type name, like string question mark. Well, as soon as you do that, that means the compiler will require you to check anytime you're using that variable whether it is nil or not. And there are several ways to do it. You can use unwrapping with if let or guard let. So here's an example. I've got this variable name. It is optional. I haven't assigned a value to it yet. And so right here, I can just check, is name not equal to nil? And if it's not nil, then I can work with it here. But a key thing to notice is that just checking whether it's nil doesn't unwrap it. And so I don't have the actual value in name. That's very different from what I'm doing here. If let name equals name. That looks weird. But what's happening is it's taking this thing that's optional And it's saying, well, if it's not nil, put it in this, which is a brand new local variable available in this block. That is so common that recently they made a change to the language to allow you to say this, which does exactly the same thing. So it's just unwrapping it, and then I can use the unwrapped value inside the block. A variation on this is guard, and this is really popular to do at the beginning of a method to say, here are some preconditions that must hold, or I don't want to do the stuff at the bottom of this method. So the interesting thing about guard is you're saying, here's a thing that must be true for me to continue, and if it is not true, I am going to get out of here. And in fact, you have to. If you forget to return, if I like put a print statement there, my code won't even compile. Guards must get out of the current context if the condition doesn't hold. And so this is also unwrapping it. So the rest of the function on the inside can use that as a non-optional value. There are other ways to do this. Here I can say with optional chaining, if the name is not nil, then what I want is to call uppercase, then I want to take that value and assign it to this variable. But if it is nil, the result of all of this will be nil, and then I use nil coalescing and say, well, if I didn't have a value for name, then I want to use this. So that's a common pattern. And then another thing, sometimes you feel really certain that this thing is not nil. In fact, you're so certain you're willing to tell the compiler, yeah, it's not going to be nil. And if I'm lying to you, it's okay to just crash the whole app. And so that's what will happen there if name happened to be nil. So that's called force unwrapping. So that's a big thing in Swift, is working with these optional types and correctly using if-let and guard-let. The way that you write anonymous functions in Swift is with a closure, and you see the syntax here. Often this is used to pass a function into another function. And so the way you write these is you put your code inside curly braces, and it looks like it's just a block of statements, but it can begin with a list of parameters. Now, if you don't have any parameters, you can just eliminate all of this and just have a block of code. But here I give names to my parameters, and I'm using type inference here. Whatever types were passed in, that's what I expect these to be. And the compiler can figure that out. But I can be explicit if I want. And if I want to do that, then I have to put parentheses around my parameter list and add the types. So this is a big deal, but it leads to this, which is a really important part of SwiftUI, is using trailing closures. So this is just a different syntax for how I could pass a function to another function. This is only useful when the last parameter, its type is a function. And so here's a good example of that. The array reduce method. I'm sure you would use this sort of thing in many programming languages where I have an array of numbers and I want to know their sum. And so here's my array of numbers and prices. And so kind of a normal way of doing this, and what you see in many programming languages, is that you call reduce on the array, and then you give it an initial value, a starting value, and then you give it a function, and that function is going to be passed the current sum, and then the next thing in the array. And then you're just going to add that on to your current sum, and it keeps going, and in the end, you get your total. And so that looks pretty common. But if you write this as a trailing closure, see, this closure is inside my parameter list, but this one is outside it. I pretended like reduce only took one argument, but it really takes two. But I can add it to the outside. And now this is interesting because it looks like it's just a block of statements. Okay, you'll see coming up why this is really useful. In fact, you've already seen it. Remember that VStack we looked at, and I had an image and a text in it? That was a trailing closure on VStack, and so it opens up some interesting syntax. You can really do better than this if you don't care so much about these names. When you have a closure, it automatically assigns the names $0, $1, $2 to all of the arguments. So I can just forget about parameters and write it like this instead. This is still a trailing closure, but I'm using what are called shorthand arguments. All right, key paths is an interesting thing, but I don't have time to talk about that. Error handling. This is a bit of a departure from what you see in other languages. Instead of having a try and a catch block, you have a do and a catch block. And the reason that they're doing this is that they look at other languages and say, you got this try, and you got a bunch of functions called inside it. How do I know which of those might throw? I have no idea. Any of them could throw. In Swift, you have to be explicit about that. And so I look at this line, and there's no try in front of it. And so I know that that can't throw, or else my code wouldn't even compile. If it could possibly throw, you have to put the try keyword in front of it, in front of every one of your calls that might throw. And also, if it is an asynchronous function, you need the await keyword. And we're going to talk about that in just a bit. So I've got a do block with a bunch of calls, some of which have the try keyword. And then here I can catch any error, or if I want, I can be explicit and tell it what kinds of errors I'm looking for. So I can have multiple catch blocks in that case. Inside this generic one, this variable error is set automatically for me. So I can just use that. If I want to throw something, there's just a small number of provided error types. Often you're going to define your own, and usually they're enums like this, an enum that conforms to the error protocol, and then I can define a bunch of cases. The cases can have data associated with it, so I'm not just saying that this kind of error happened, but there's data that goes along with it. And if I want to be really lazy, I can just add an extension to the string type and say, I could throw any string. If I just write this little bit of code, then I can do this sort of thing and throw a string. There is no finally that goes with do catch, and that's an important thing, right? You need to say, I don't care whether it worked or it didn't work. Here's some code I need to run at the end. And so the way you do this in Swift is with a defer block. And so I would put this above my do catch, and this says, when I exit this scope, here's something I'm going to do at the end. So it'll run whether I have an error or not. If I want to have asynchronous functions, then I declare them like this. This async keyword goes after my parameter list. It doesn't have to also throw, but if it can throw, then I need both of these keywords. And now that I've made this async, it's allowed to call other async things by using the await keyword. So here I'm getting my current coordinates, my latitude and longitude, and then I'm looking that up to find out what is my mailing address. And then I'm pulling out of that my city. And so that's the job of this function. So if I want to call this, I have to call async functions inside a task. There's two ways to create a task. One way is with this task block. Another way is that in SwiftUI, there's a task view modifier. We won't talk about that anymore today, but that's just a second way to do it. Okay, so I can't be calling asynchronous functions unless I'm inside a task. And now that I am, I'm allowed to use the await keyword. So if I forget this, my code won't compile and it'll say I wasn't in a task. So here I try to do something. If this throws, then I'll end up down in this catch. But if it doesn't, then I could do something with the value of city. All right, so that's enough talking about Swift syntax. Yeah.
Would the defer have to be inside the task too for that do catch? If you did that section?
I don't believe so. No, because it just needs to be known inside the function that I'm writing so that it knows when that function goes out of scope, then it's going to call that defer block. Yeah. Real quickly, there's a Swift standard library that defines a bunch of common things. You get those for free. You don't have to import anything to use them. Then there's the foundation framework. You do have to import foundation. You don't have to say what you want from it. You just say import foundation, and then you get these other things that are also commonly used, but not quite as commonly used as the Swift standard library. All right, so now on to SwiftUI, the main thing that we're here for. So everything that you render on the screen is a kind of a view. There are a lot of built-in kinds of views, simple things like buttons and text fields. And then there are some container views. Earlier we saw VStack with a vertical stack of views. There's also an HStack for horizontal, and then a ZStack for putting things on top of each other. There are other kinds of containers like a form or a list or a scroll view. And then you can define custom views that combine all of these things. I mentioned the SF symbols library. This has over 4,000 icons that you can use in your apps. And one of the goals of using these is that your apps look like other Apple apps because they all use the same kinds of icons. So to use one, you just say, I want an image view, and then system name is what says, I want something out of SF symbols, and then you give the name of it. So SF symbols is actually an app that you can run on your Mac, and you can look through the collection of icons and click on one, and you'll see what its official name is. Some of those symbols have multiple rendering modes, which allows you to have multiple colors inside the icon for different parts of it. And some of them, you can give it like a percentage value, and that'll change what parts of the icon are actually rendered. All right, I mentioned view modifiers earlier. Remember I said that you apply it to a view and it returns a new view to you. You can chain these things together to apply multiple of them. From the web world, when you think about CSS for styling, that's what you do with view modifiers, although many of the view modifiers aren't related to styling. This is how you do styling. The order is really important. So if I add padding to a view, and then I add a border, the border is outside the padding. But if I do it in the opposite order, and I add a border and then I add padding, the border is right next to the view and the padding is outside it. So you have to think about the order in which you're applying these. And then a lot of your views need to manage some state. And so the thing to ask yourself is this data that only this one view cares about, or is it data that multiple views need? Well, if you only care about it for that one view, then you want to use this approach. You use the @state property wrapper to mark a property to say that this is holding data that can change. And this is important because my views are structs. Remember we said structs are immutable, so I can't be changing properties inside it. But if I have an @state property wrapper, what I get is a constant reference to non-constant data. So it's held outside my view, and I can make changes to it without actually changing the view itself. This is the golden slide. This is what we all came for. If you understand what's on this slide, you're really ready to go with SwiftUI. So let me jump over and demonstrate this app real quick. Here it is running inside the simulator. If I type in a name here, Mark, popped up, hello, Mark. And then if I hit this toggle for show heart, it opens up that section, toggle back off, it disappears. And here I can toggle whether the heart is filled. And down here, I can pick a different color for the heart. So that's everything that we're doing on this screen. There you go. Okay, so let's look at how you do all of that sort of thing. So for starters, my custom view is a kind of a view. And that means I have to have a computed property named body. And all the rest of this is optional. So there's 4 pieces of data that I care about here. I want to hold on to a color. So it's a private variable. It's only for use in this code. Its name is color, its type is color, and it starts off with a value of red. I can just say .red, and it knows with type inference that's a kind of color. Then is it filled? It starts off false. What is the name that I'm going to type in here? Starts off as an empty string. And what's the state of this toggle right here? It starts off false. Then I have a list of colors, red, green, and blue. That's going to be for these options down at the bottom. And not ready to go. So I create my V stack, a vertical stack of all of these things. This spacer is a way of saying, I want to take all the things that I'm going to display and I want to shove them up to the top of the screen. If I didn't do that, it would be centered on the screen, which might be what I want. But in this case, I wanted to push it up to the top. So that's what the spacer does for me. And right where this comment is where all this code comes into play. So starting from the first line here, I have labeled content where the label is name. And then over here is a text field. It looks like I'm repeating myself by saying name twice, but actually that second one in the text field, that's the placeholder text that you would see if there's no value in there, like gray text inside. Then that $sign in front of name is really important because I have to pass to text field a binding so that it can make a change to the value. So I can only do that if it's a state property, and that's what I have. And then text field style, that's a view modifier to say I want to see a border around that. It's hard to see here, but there's a border with rounded corners there. Then I check to see if the name is not empty. That's kind of cool that Swift has this is empty that you can check on a string. So if it's not empty, then I want to display this bit right here. It's text. Here I'm using string interpolation. And then I'm setting the font to be large title. So that's a dynamic font size. There's a bunch of predefined enum cases that I can use. This is very different than saying I want it to be a 40-point font, because then it would be that for everybody. With this, the actual size depends on the setting that the user has on their phone. So it can change if someone has some vision problems and they want to bump up the text. Then this toggle right here, it should say show heart, and it also needs a binding. Is it on? Well, look at a binding for show heart, the Boolean over there. And then if it's true, I want to display all the rest of this stuff. So I want to have an image here that is either heart.fill or heart. Changes based on whether filled is true or false. And then I want this to be bigger than it would normally be. And so in order to change the size of an image, you have to say that it's resizable. And then I want it to scale to fit inside whatever I give it. I don't want the aspect ratio to change. And then I want it to have a width of 100, and then it'll calculate the height for me. And then foreground color is whatever I have the color variable set to. Then toggling whether it's filled is the button right here. And that is going to just toggle the value of the Boolean. So toggle is a method on Boolean values. And then finally, the picker. That's what this thing is at the bottom. And in fact, it's a segmented picker. There's different kinds of pickers, like the drop-down list is one. But I want it to be this segmented kind. And so for the picker, I want to tie it to this binding to color. And then I say what goes in all those sections of the picker. And then the dot tag is associating a value with each one. And that's the value that will get assigned to color if you click on it. Okay, any questions about this? Yes.
The state property finding, that makes sense. What would happen if you did have that? They can't have age, that's what they call the at things.
Are you talking about the dollar sign?
At state.
Oh, right, yeah. A property wrapper or
You
something.
didn't have that.
I
You
didn't have
just
it.
passed in that is on, you just passed in the name of that.
Yeah, I would say
property
you
that
can't
there
get a binding of something that's not.
So it has to be a binding.
Yeah, it won't compile if I leave off the state. And then here, if I had the state, but I leave off the dollar sign, it'll say, hey, you gave me something that's not a binding, that won't compile. Yes.
You hold that a property wrapper, the main also have that at sign on it, yeah.
Sorry, with many property wrappers.
So you can make your own, I presume.
You can,
and there's
yeah.
events or something that, yeah, okay.
Yeah, there's a syntax for implementing your own property wrappers.
And then the dollar sign in front of name and in front of color, like, is that, I'm interested in what the language is doing there. Is that referencing a different property that's created by that state property wrapper? Or is that?
I think that's right.
The link there.
But the key is that I'm passing it a thing so that this view can make a change to it, and that'll be reflected back. If I just passed it a bool value, it wouldn't be able to do that. But I'm giving it a way that it can make a change and that I'll know that it changed it.
Yeah, that's cool.
Yeah. All right. So I mentioned earlier that you need to ask yourself, is this data only needed by this view? Or do I need to share this with other views? If you need to share it with other views, then you should instead create a thing that's called a view model. A view model is just a Swift class that inherits from observable object, and it has properties that are annotated with @published property wrapper. So once I create one of these view models, I have to think about, well, how will all my views know about this thing? Well, there are three ways you could do it. One way is to inject it into the environment. And that's a way of saying, there's only one of this kind of thing. I'll tell you about it. And then any of my views can go find it based on the type. Another way is that I could pass it as an argument. And then a third way is that I could just make my view model be a singleton. And then everybody could just grab the one instance of it. But we're going to look at the first option, injecting it into the environment. And so I do that with this .environment object view modifier. And then in all the views that need it, they'll use @environment object to get it. And so here's a simple example of this. At the top here, this is the beginning of my app with the @main, and I'm going to make a simple blackjack scoring application. And so on my content view, which is defined over there, I use this view modifier environment object, and I create an instance of my view model and pass it in. And here's my view model. It's really simple. It conforms to observable object, and it has one published property, which is the score, and it starts at 0. I could have more published properties, and I could have methods in here that do things to this data. This is just a really simple view model. And then over here, my content view doesn't actually use my view model, but it does have these other views, form and report. And so here's form and here's report. Those two need it. So form is this part right here. It has this stepper view so that I can change the score. And that's all that I have here, a stepper. And I've got my view model. Here I say, okay, give me this thing. So there has to be just one instance of this because it's looking it up based on its type name. And I put it in this variable called VM for view model. And then here I can pass a binding to that score. So if I click on the plus and the minus, it's going to change that value over in my view model. And then down here in the report, I have the same line of code to say, yeah, I also need access to that same view model. And then in my body, because I'm a view, I need to have this computed property. I want to display what is the current score, and then what is the action that this blackjack player should take. So that's this part right here. Well, action is a computed property right here. It's going to return a string. And so I can get the current value of the score, and I'll say, okay, less than 18, then let's take another card. If it's greater than 21, I've lost. If it's 21, I've got blackjack, but otherwise I'm going to stand with that. So that's it. I have two views that both need some data. It's declared in a view model. It's injected into the environment, so any of my views can grab it, and they can change it if they want. If they do, the other views are going to update. In the world of Svelte, this is like a Svelte store. Any questions about that? Okay, so there's a bunch of slides coming up that I would love to talk about if I had more time. There are a couple of ways that you can say to a property, I want to know anytime it is changed. It's about to be changed, already changed, and so that's what this slide summarizes. Then back to SwiftUI, you might want to have ways of navigating to other screens in your app. And so here I've got some things that I can click on, and this code is showing how do you set up that kind of navigation to go from one screen to another. You see right here, Apple View, Banana View, Cherry View. Those are described right here. They're just other views that in this case, they represent an entire screen in my app. And so the key here is that I have a navigation stack, and then I have navigation links for going to a different screen within my app. Tab views, a lot of applications have tabs at the bottom of the screen, and when you click them, it displays something different in the middle. And so I've got a navigation stack so that I can have a nice title at the top. That's one of the things navigation stack does for me. And then my tab view has these different screens with all of different tab items. That's the thing that will appear down here. And when I click on it, it'll display that view for me. And so here are just 3 separate views. So I can have a tab view kind of a UI. I might want to pop up a dialog or a sheet. So an alert looks like this, and alerts can't do very much. You really can only have text inside there, or maybe an image. You can't like put form inputs inside that. If you want to have form inputs, then you need to create a sheet, and that pops up from the bottom of the screen, and you can control how much vertical space it uses. But here I can have text inputs and pickers and all kinds of form inputs. And so this slide just summarizes how you do that part of a UI. You can send network requests. And so I want my mobile app to talk to Micronaut APIs. And so I can send an HTTP request, It's a little tricky. You have to use this URL session thing, and it doesn't look quite as clean as, say, using the fetch API in JavaScript. I keep thinking that at some point, Apple is going to provide a more polished interface for this. But in this example, what I'm doing is I'm getting a response back from this HTTP GET request, and then I'm expecting to get JSON data back, and so I can use this JSON decoder to decode that. And I'm actually talking to an API that returns a joke to me. There's like a punchline and the setup of the joke. And so that's the data that's actually coming back. You see that URL at the top there to the joke API.
Yeah. Sorry, Chris, quick comment, question, but it looks like, so guard let response, you talk about that, that's doing the unwrapping.
Yeah, so saying if the thing that I get back is not an HTTP URL response, I can't deal with that.
Right.
So I'm gonna throw an error. And then after that, if I don't get a 200 status, I can't continue on. So
Maybe I missed that, but I didn't realize that guard works for any condition.
Oh, yeah.
It's not just
optionals, not just checking
optional.
optionals.
Okay, that's cool.
That's all right.
We're down to a few minutes left, Mark. So
Okay.
take questions. And
Yeah, I'm pretty close to the end here. There's a bunch of options for how you might persist data. You can store it on the device using something called app storage. You could use core data, which also stores it on the device, and it uses SQLite. You could use CloudKit to store your data out in the cloud. Realm from MongoDB is another option. We've got some recommendations for how you might structure all the files in a project. So options for deployment. You got to get this out to the App Store at some point. And I really like using this thing called Fastlane. It's a way of just kind of scripting all of these things that you want to do, like generating screenshots and putting your app out into test flight, which is where beta testers can use it, or to the App Store where you're really going to deploy it. So we've seen a lot of parts of the Swift programming language and a lot of parts of SwiftUI. Of course, there's much more to learn. And so if you check out my blog that you'll see on the next slide, you see a list of the topics that I cover there. I want to close by saying this was very Apple specific, but of course you might want to create an Android application. And if you wanted to do that, you should be looking at the Kotlin programming language, and you should be looking at Jetpack Compose, the framework. It's very similar to SwiftUI, it's just Android specific. And then one last slide, again, my blog. There's a lot of information about Swift and SwiftUI that I haven't had time to go over today. And then there's all these other topics, different frameworks and tool sets that are involved in iOS and Mac development. So there's a separate blog page for every one of these topics. So check it out and let me know if you have any questions. And I think that's it.